Hi there, in this video we're going to try a past exam question on trigonometry. So question 2 part A showed that the equation 5 sine x is equal to 1 plus 2 cos squared x can be written in the form 2 sine squared x plus 5 sine x minus 3 is equal to 0. Now one thing to note is that the equation that we need to show doesn't have a cos squared term. So this indicates that we may need to use the Pythagorean identity cos squared plus sine squared x is equal to 1 in order to rewrite that cos squared term as a sine squared term. So let's do that. So back to the paper and pen. So here is the equation as it stands. So as discussed, let's use, by using the Pythagorean identity cos squared x plus sine squared x is equal to 1. Now let's rearrange this identity for cos squared. So cos squared x, when I rearrange, is 1 minus sine squared x. And let's replace the cos squared x term as a result by 1 minus sine squared x. So to give us 5 sine x on the left hand side, that is equal to 1 plus 2, and cos squared x is 1 minus sine squared x. So let's replace that term. Now from there on, let's multiply these brackets to give us 5 sine x on the left. That is equal to 1 plus 2 times 1, which is 2. 2 times minus sine squared x is minus 2 sine squared x. Now if I bring these three terms on the right hand side to the left hand side, we're going to have, so the minus 2 sine squared x to the left is plus 2 sine squared x plus the 5 sine x. 1 plus 2 is 3, but if we move that plus 3 to the left also, we'll have minus 3, and that is equal to 0. So that is the very equation that we need to show. So that's the idea of 2 part A. Let's go back to the question. So for part B, we need to solve the quadratic that we've shown, 2 sine squared x plus 5 sine x minus 3 is equal to 0, and we need to find all of the angles x between 360 and 0 inclusive. So let's get back to the paper and pen. So here's the quadratic in terms of sine that we need to solve. So what I tend to do is, since I have sine x terms in my equation, in my quadratic equation, let me replace the sine x by a letter t. So if I let t equal sine x, so that the above equation becomes 2. If t is sine x, then sine squared can be replaced by t squared, plus the 5 sine x, let's replace that by t, minus the 3 is equal to 0. Now you don't need to do this. You can solve your quadratic involving sines, then you'll have 2 equations involving sine to solve. However, the idea in my case is I'm going to find the values for t first, then I'm going to go back to this substitution that I've chosen to find 2 equations in terms of sine that we need to solve. Now I have a quadratic over here. Now you can either factorize or you can use the quadratic formula in order to solve this quadratic. Now I'm going to factorize, and if you were to factorize, the factors will be 2t minus 1 and t plus 3. So here are the factors for this very quadratic, and using this equation you have 2 values of t. So either 2t minus 1 is 0, which means that t is half, so that is one of the values of t, or t plus 3 is equal to 0, meaning that t is minus 3. So we have 2 values of t in this case. Now, if I go back to the substitution that I've chosen, so t is sine x, and I have two values of t. So let me plug in these two values of t into this equation. So since t is equal to sine x, let's find an equation for when t equals half. So when t is equal to half, that means that sine x is equal to, replacing the t by half will lead us to this equation. So let's call that equation number 1. And let's do the same for when t is equal to -3. So when t is equal to -3, so if I replace, so going back to this equation, if I replace the t by -3, this is what we're going to have. We're going to end up with this equation, sine x is equal to -3. So here are our equations. This is equation 1, sine x is equal to half. Let's number this equation number 2. Now, let's focus on equation number 2. Now, this equation cannot be solved simply because sine x has a range. As you may know, the range of sine lies between plus and -1. So this equation cannot be solved, so let's neglect that equation. So remember, let me repeat, sine x has a range between 1 and -1, and as a result of this range, we cannot solve this equation, sine x equals -3. It cannot be solved. So let's go back to equation number 1. And let's solve this equation, sine x is equal to half. Now, to solve this equation, I'm going to be using the cast diagram. If you're unaware, in order to solve trigonometric equations like this using a cast diagram, I'll provide a link to the videos that I've created explaining the process in the description below. So let me show you how to solve this equation using the cast diagram. So we're going to solve equation number 2, which is sine x is equal to half. Now, the first thing to note is that the half on the right hand side is positive. So we're solving sine x equals plus half. So we have sine x being positive. So positive means we need to plot the angle where sine is positive on our cast diagram. So to find the angle that we need to plot, let's work out the inverse sine of half. And the inverse sine of half is 30 degrees. So that's a standard result in that sine of 30 gives you half. So going back to what I said, we need to plot the angle which is 30 degrees where sine is positive. So let's have a cast diagram. So let me include the quadrants on the diagram. Let me label the quadrants, so all, sine, tan and cos. So remember, we need to plot 30 degrees where sine is positive, and sine is positive in the all quadrant, and sine is also positive in the second or in the sine quadrant. And when plotting the angle 30 degrees is always plotted from the horizontal. So from the horizontal in quadrant number 1, so from the horizontal, this is roughly 30 degrees represented in quadrant number 1. And from the horizontal in quadrant number 2, so again from the horizontal in quadrant number 2, this is roughly 30 degrees. So just a judgment of 30 degrees in these two quadrants. Now, when working out the solutions are always measured from the 0 line, called the initial line. So let's measure the solutions from the initial line. And if we go back to the screenshot, we need all of the solutions between 360 and 0 inclusive. So back to the paper and pen. So the first solution using the cast diagram is from the 0 degree initial line in the anti-clockwise direction, because we're measuring positive angles, and positive angles are measured in the anti-clockwise direction until you hit that first line drawn, and that angle is 30 degrees. So the solutions are, so the first solution, which I'm calling x1, is 30 degrees, as discussed. And we can have another solution, x2, another solution, so let me take another different colour, is measured from the 0 degree line, again in the anti-clockwise direction since we're measuring positive angles, until you hit that second line being plotted. So that angle from here to here will be 180, the angle in a straight line, minus 30 degrees. And 180 minus 30 is 150 degrees. So these are the only two solutions which are possible for this equation over here. And these are the only two solutions given that the range given in the question is all of the angles x between 360 and 0 degrees inclusive. The reason for that is if you were to calculate another solution, it's going to go beyond your range. Another solution will be the angle from here, from the 0 degree line, right round, which is 360, plus another angle of 30 degrees to strike that first line. So 360 plus 30 is 390, and that is beyond the given range. So all in all, two solutions for this particular question. So that ends the question, and that sadly ends the video. So if you found this video helpful, a like rating is very much appreciated. Do plenty of practice related problems, and I hope to see you soon. Thank you.